Thank you very much. Good evening. I'm going to present a very short lesson on solving simultaneous equations in three variables. During this COVID time, feel free to subscribe to my YouTube channel so that whenever I download a lesson, you're able to follow it. So we're going to begin with an example that I've set. If we have x plus y plus z equal to 6, 2x plus y minus 3z equal to 4, and we have 3x minus 2y plus 2z equal to 2. Okay, so these are the three equations, and we have three variables that we need to calculate. So the first step, we should name these equations so that it will be very easy for us to refer back. Okay, I've used the Roman numerals 1, 2, 3 to label the equations. So we're going to solve these equations using what is called elimination method. Elimination method. Okay, so we're going to solve by elimination, meaning that we need to do away with one variable in order for us to remain with two variables, and then we go back to the way we used to solve simultaneous equations in grade 9, which were very simple. So we are going to eliminate x. We are going to eliminate x. So the x part will be eliminated, we shall remain with y and z, then solve in two variables. So that will be extremely simple. So we are going to start with equation 1 and equation 2. So in equation 1, we have x plus y plus z equal to 6. Equation 2, 2x plus y minus 3z is equal to 4. So we are going to multiply the whole lot of this equation by 2 so that this x and this part that has x and this part that has x will be the same, so that we can do away with it. So we'll have 2x plus y plus z equal to, even this one will be 2y, even this one will be 2z, then will be equal to 12. Then 2x plus y minus 3z equal to 4. So we're going to use subtraction because this one is positive 2, also this one is positive 2. So if you use the subtraction sign, these will be eliminated. 2x minus 2x, we get 0. 2y minus y, we get a y. 2z minus 3z, we get positive 5z. And 12 minus 4, we get 8. And we're going to name this one equation number 4. Okay, so this is how we find now an equation in two variables. Okay, next we're going to eliminate x in 1 and 3. Equation 1 and 3. So in equation 1, we have x plus y plus z equal to 6. And in equation 3, we have 3x minus 2y plus 2z equal to 2. So in this one, we're going to multiply the whole equation by 3 so that this x part will be 3x, so that these two will subtract exactly where we worked on this one. So we'll have 3x plus 3y plus 3z equal to 18. 3x, this one we shall pick it as it is, minus 2y plus 2z is equal to 2. So again here, I'm going to use the subtraction sign. So that this one is 0. 3y minus gives us positive 5y. 3z minus 2 gives us z. And 18 minus 2 gives us 16. And we are going to label this one number 5. Okay. So we have two equations. So these two equations, we shall solve them simultaneously as well, so that we find the value of y and z. So we have y plus 5z equal to 8, and we have 5y plus z is equal to 16. The same way we were solving here, we shall make sure that this y becomes 5y, so that we eliminate y. So we shall multiply by 5 the whole equation, just like we multiplied here, So we have 5y plus 25z is equal to 40. Then we have 5y plus z is equal to 16. When we subtract, we have 0y, we have 24z is equal to 24. So 24z equal to 24, we divide by 24 here, we divide by 24 here, so our z is equal to 1. So we found the first one, we found the z, found the value of z. So we substitute z into one of these. We can substitute here, or we can substitute here. So if we're substituting this one, we shall say in 4. So it will be y plus 5, 1 in brackets as a substitute is equal to 8. So y is equal to 8. When we transpose 5, we subtract 5 here, we subtract it there, we'll get 3. So we have a value of y. So once we have a value of y, we can now substitute z and y into, for example, equation 1. The first one given here, such that we have x, we have y. Remember that we have the y, we have the z. So we can simply substitute the y here and the z there. Once we substitute these, we'll have x plus 3 plus 1 is equal to 6. So 3 plus 1 is 4. We subtract 4 here and subtract 4 on the other side. We have x equal to 2. Therefore, x is equal to 2, y is equal to 3, and z is equal to 1. So this is our answer. This is our answer. Okay, let me just go through very fast. We have equation 1, equation 2, equation 3. We choose any of the variables that we must eliminate. So if we say y, we should eliminate y so that we can solve x, and z the way we used to solve in grade 9. The same way, if we want, we can eliminate x so that we solve y and z. So the elimination is to reduce the variables from 3 to 2 so that we go back to what we know, the grade 9 work. So here we chose to eliminate x, and I've indicated so that in case a person wants to follow our work, it will be easy for that person to follow the work. So since we have this equation, which is different from this one, we make sure that this variable, this coefficient and this coefficient here should be the same. So we multiply the whole equation by 2 so that they are the same. Then we subtract and we get equation 4. We do the same using equation 1 and equation 3. You can even choose to do it using 2 and 3 so that it becomes easy for you to eliminate. Okay, so here we eliminated and found equation number 5. And we've solved equation number 5 and equation number 4 simultaneously, like the way we used to solve in grade 9, and then we find the value of z. Substituting the value of z in 4, we found the value of y. Substituting z and y into equation 1, or you can use equation 2, or you can use equation 3, it will give you x is equal to 2. And then finally you state x is equal to 2, y is equal to 3, z is equal to 1. Which you can actually prove back using these 3 equations. 2 times 2 is 4, y is 1, 4 plus 1, 5. Okay, so we keep that 5, then 3 times 1, 3. So 5, let me go again, this one is 4. 4 plus 3, which is y, we get 7. 7 minus 3 times 1, which is 3, we get 4. So these are correct. Thank you very much. Do not forget to subscribe to my channel. Good night.